Hey Greg, how you doing? It's Harry. I'm putting this video together so that you can take a look at what I'm thinking. I basically took the presentation that we did the other night and I rearranged it in a little bit slightly so that I thought it would flow better for someone who wasn't there. I'm going to go through it. Obviously, if I made one, it would be a lot more passionate and excited and move through more quickly, but basically I'm just going to talk you through the kind of things that I'm thinking. Thought I'd start off and address the fact that the other evening, Wednesday, December 11th, we met with the Glenville PTA to discuss some strategy to help the students be more successful. Explain to them just a little bit of background that in the United States, traditionally we've had each state had their own curriculum. Recently, we've gone to what's known as the Common Core State Standards, and 45 of the 50 states have all joined on. All the yellow states have joined, and Connecticut is one of them. That would mean that if a kid were to move from one state to another, they would be learning the same material in each grade, and that would keep the consistency. Now, why did we do this as a nation? Well, uh, there are international tests that are given every few years, and countries are ranked to see whose students are performing at the highest levels. Here is some information from TIMSS, the Trends in Math and Science Study. You can see that here's the fourth grade data and the eighth grade data, and that the top five countries, Singapore, Korea, Hong Kong, China, and Japan. If you look over here at eighth grade, they're the same countries. They're in a slightly different order, but basically these countries are the top five performing countries in mathematics pretty consistently. And the United States, we're not exactly ranked even sixth. We're even further down. I think we're like ninth at fourth grade and 11th or so at eighth grade. And even lower at 15, 16-year-olds, we're actually ranked 36 in the world. So the United States has designed these Common Core standards to help us understand what we could do differently to help our students perform better. In a traditional classroom, the emphasis in the United States has always been on being able to solve a problem and compute the answer. And most of our energy was spent on teaching kids the computational strategies. So a problem like this, most of the energy was spent on teaching the kids what numbers to cross out and what numbers to change them into. And that was the main focus of our instruction. In Singapore, where they're consistently scoring higher, they have a completely different approach. What they do is they take any concept and they teach it from a problem-based methodology, and it should be a problem that the kids can readily understand in their own life. So an example might be something like Tyler's teacher asked them to arrange 31 pencils, so they'd be easy to count. Because if there's 31 just laying on a desk, you'd have to count them every single time. So he's going to arrange them. Then the teacher asked him to pass out 15, and the question is how many pencils were left. So as you can see, to make it easy, Tyler would bundle them into groups of 10, and he would have 10, 20, 30, 31. Now the trick for that is that when you go to take away 15, if I have my 31 here, 10, 20, 31, it's easy to take away 10, but to take away 15 is not easy because they're in bundles. So what I would have to do is take one of my bundles of 10 and break it into 10 ones, to separate it. Basically, what I would end up now is two bundles of 10 and then 10, 11 more. So basically, it's 20 and 11 instead of 31. But again, when you put 20 and 11 together, you're still at 31. Now, what would that look like in a classroom? Well, you'd start out with 31 and you want to take away 15. These are tools that students use all the time in class. They're called base 10 rods. Base 10 rods. They stick together. This is a 10, 20, 31. You ask students, can they take away 15? And they can't because they need to take away 5, but there's only one loose. So what they do is they take one of the 10s and they break it up. They trade it in and they break it into units. So what they end up with is now 2 10 rods and then 11 loose. And then they subtract. Now, if you think about it, this is the work that we did when we were in school. Basically crossed out the 3, made it a 2, and changed the 1 into 11. But now a kid can really understand why we're doing that. You used to have 3 rods in one unit, that's the 31, and now we have 2 10 rods and 11 units. And then you subtract. So when a kid does the work, it's very easy for them to understand why we are doing this. Also, when it converts into a word problem, it's easy for them to understand it as a model. So this model right here is called the bar model. This is very big in Singapore since they're solving word problems all the time. They learn how to translate little question stories into models to help them understand. So in our story, Tyler had 31 pencils. He gave away 15, which is part of it, and we want to know what's the other part of it. And again, same work we always did, 31 minus 15 equals 16, except now the kids are able to understand why we crossed out the 3 and made it a 2, and why we crossed out the 1 and made it an 11. Because they teach this way, one of the things that's kind of amazing is how difficult of a question kids are able to do at a very young age. This one comes out of the 4th grade and is something that students in America generally don't engage in until they're 8th or 9th grade. So a problem might be Jamie had 4 times as much money as Morgan. After Jamie spent $26, Jamie had $2 less than Morgan. How much money did Jamie have at first? Now, this is a problem. If a student was taught the traditional way of just computing and getting the answer, they probably wouldn't even know what work to do for this problem. So basically, in Singapore, the kids are taught not only how to solve problems, but they're put into a context so that students are able to use models to help them solve it. In case you're interested, this is how they would actually make it. It says Jamie has 4 times as much as Morgan, so basically they would draw a model for Morgan and then say Jamie has 4 times as many. And then basically it says Jamie spent $26 and then still had $2 less than Morgan. So from the total, Jamie spent $26, but that was $2 less than what Morgan had. And basically from that, you can solve it and find out that each unit is worth $8. So Morgan had $8 and Jamie had 8 times 4, $32. That's a problem that normally in the United States would not have even been addressed until 7th, 8th, or 9th grade, and probably would have been solved in algebra. But in Singapore, it's something that students are engaging with at a much younger age. So now let's go back to the data. Looking at the kinds of examples we just did of how to solve the problem and then the type of word problems, it's a little bit easier now to see why consistently these countries, Singapore, Korea, Hong Kong, China, Japan, are consistently scoring higher than the United States. It's because they are using those strategies. They really help the kids understand how and why to solve a problem, and then they focus on word problems. Now, in the United States, most school districts are trying to find a curriculum that lines up with this type of teaching. So the district in Greenwich has chosen Math and Focus. It's basically they took the Singapore books that the students were using, translated them into English, and adjusted them so that the kids would use the same type of curriculum. Now, the challenge for students begins when if we were to implement at kindergarten, basically the kids were to start at kindergarten, progress to 1st grade and 2nd grade, they would learn these strategies a little bit at a time. The challenge is if you implement like the way that we have at a different grade level, for example, 3rd grade, there's a lot of skills that the students have missed in the past. A lot of they were taught differently, so they might not have mastered it the same way. And traditionally, they did not do a lot of word problems. So that leads to a transition problem. It's not the fault of any teacher, it's the fault of, it's not even the fault, it's the challenge you run into when students are brought in midstream. So a lot of the students have been having difficulty. That's why we had this whole parent night in the first place. Now, if you were to start and break it down into small levels and see what the kids would have done from kindergarten to 1st grade to 2nd grade to 3rd grade, what you would find is that you can break it down into very small levels. Kids master each level and they progress along. The challenge is this year some of the students began at 3rd grade, and that's way down here at, say, level E, F, or G. And what happens is since the students didn't have the experiences of level A, B, C, D, and E to learn some simple problems, to master them, and to gain the confidence that they need, then they have run into challenges this year. And it's very common, happens in all school districts where they implement kids that at any grade level other than kindergarten. So basically, East West Math, we were contacted to come in and offer some ideas of how to help. And what we did was we were putting together a program. It would kind of be run on the basis of a club. It would be after school. We haven't decided the day yet, But the idea is instructors from East West Math and myself are going to come out and help the kids learn all the types of problems that they would have learned in previous grades. So third graders will learn what they could have learned in kindergarten, first, second, and then fourth grade what they could have learned in fifth grade. And the idea is to catch them up to the level that they're expected to be functioning on. Basically, what we're going to do is help them take a problem like Coach K had 5 blue cubes. He found 4 yellow cubes. How many cubes did he have altogether? We'll have them solve it. Then we'll use the bar model. We'll show them how that evolves into a bar model. That 5 and 4 becomes a total of 9. And we'll go over what they missed in kindergarten, first, second, third grade to get them caught up. The way the program will work is each week we'll get them together. We'll take step by step, level by level. We'll do an example. We'll show the students how they work. Then we will have some guided practice. We'll have problems that have models that just are missing the numbers. And when it looks like they can do that, then we'll give them some independent problems where we'll just give them the problem. The students will draw the models, and then the students will solve the problems. And I've been doing this program, helping kids with this, so I'll be in the room to help the kids if they have any trouble. And basically, if you're interested in this, you can contact the PTA. We're going to arrange a day. We'll provide you information. But at least now, if you were for any reason unable to attend the parent night, now you would be able to see what the program is, when it's the concept behind it. And again, the PTA will provide you information as far as cost, number of students, and when the classes will be offered. Thank you. So anyway, Greg, that's kind of the basic idea. Of course, I will flow much better because I'll practice that one, but basically this gives you an idea.